So backends can be created. They also need to be registered, and you can do this via the register function. So by default, Windows will use the Snow backend and Mac will use the multi-core backend. But if you want to fall back on a serial execution of your tasks, you can register the Serial backend. And with this function, I can now check which backends are registered. Both of them are there by default, but this one is now the one that is registered and that will be used. If you register a backend, it will be displayed at the top of the list, and that means that this is the one that will be used. This function will directly give you the backend that is being used at the moment. So since we registered the serial backend, that's the one that is being used. So BIOC parallel provides a function called bpapply, which is the parallel version of lapply. It works exactly the same as lapply. So it has the same arguments, but it will do the function in parallel. So the code is exactly the same as for the lapply. The only thing that you need to change is this. You have to specify the backend that you're going to use. And you do this via the bparam argument of the bplapply function. So, and here in this first example, I'm specifying the serial backend as the one that I want to use. So I create it and I give it a name. So I can refer to it here. Let's run this code again, but this time using bplapply. And you see that it takes as long as our previous attempt. So 9 seconds. And also here, 9 seconds. It does work. So we can, for instance, take a look at the results and you see that I indeed have a peak-picked spectrum. So it does work. There's just no gain in time because I'm still working in a serial way.